Section 9.3 is on the area of trapezoids and kites. So for this, we are going to start by going over our area formulas. And the nice thing is about these area formulas is that the area of a kite and the rhombus are found using the same method and using the same formula. So when writing this out, the area of a kite is equal to 1/2 times diagonal 1 times diagonal 2. And this is the same for a rhombus. 1/2 times diagonal 1 times diagonal 2. So a few things that you might want to remember about a kite is that the vertices that are formed by two different side lengths, that forms a diagonal that is bisected by the other one. So those two short segments are congruent to each other, but the other diagonal isn't bisected, but that one is, so that will be able to help you find some information you need in some of the problems. Also, it forms 4 right triangles. Same thing with the rhombus. It forms 4 right triangles when you have all 4 diagonals drawn. Also, both of the diagonals are bisected. So that means they are always cut in half when both are drawn in the picture. And the next example is, or shape, is a trapezoid. And the area of a trapezoid is equal to 1/2 times the height times the base 1 plus the base 2. And you'll notice that the height isn't always on the outside of the shape. It is usually on the inside of our object. It can be on the outside if and only if one of the edges is a right angle. Then we would be able to have the height on the outside of the shape. So now let's do some examples. The first example is a free throw lane on an international basketball court is shaped like a trapezoid. Find the area of the free throw lane. So the area of a trapezoid we just went over is 1/2 the height times base 1 plus base 2. In this one, they already told us what the height is, which is 5.8 meters. So we're going to plug that in. And then we also know the heights of the bases, or the lengths of the bases, as 3.6 and 6 meters. And those we are going to be adding together. If you want to type this all into your calculator in one step, when you type it in, you can type 0.5 times 5.8 times 3.6 plus 6. And notice that you will need these parentheses in order to get the correct answer on your calculator. If you don't put those, it's going to multiply before it adds, and then it will result in the wrong answer. So I'm just going to pull up my calculator. Answer equals 0.5 times 5.8 times, in parentheses, so don't forget those, 3.6 plus 6. Enter. Area equals 27.84. And remember, when we're working with area, it's going to be our units squared, so we're going to have meters squared. All right, our next example. We have a rhombus PQRS that represents one of the inlays on the guitar in the photo. Find the area of the inlay. So they told us this is a rhombus, which has the area formula of 1/2 times diagonal 1 times diagonal 2. And if you remember, a rhombus, when it has the diagonals drawn, they are bisected, so they're equal to each other. So the full length of the diagonal going left and right is going to be 12 plus 12, which is 24, and that can be our diagonal 1. And then the full length of the diagonal going up and down would be 9 plus 9, which is 18. And now that we have that information, we can go ahead and plug it into our formula to figure out what our area will be. And this one, because we're just multiplying, you don't need to worry about putting parentheses in your calculator when you type it up. And we would get 225 millimeters squared for our answer. So the next part, the extra practice, I would like you to pause the video and try these on your own, just to double check to see if you have an understanding of how to find the area of each shape. Once you have your answers, press play and then check your work. So our first one, we have a trapezoid, and the area formula for that is 1/2 height times base 1 plus base 2. And when you plug that in, hopefully you had 1/2 times 4 times 6 plus 8. And the reason that we use the 4 as the height is because it is perpendicular between the two bases. So it is okay to use that as our height. And this one, we would have 28 feet squared. Then, for example 2, this one is a kite, which again, the area is 1/2 times diagonal 1 times diagonal 2. And this one, we would have 1/2 times 6 times 14, so they gave us our diagonals right away. And that would end up being 6 times 7, and that would be 42 inches squared. So if you didn't have the correct answer for either of these, you can pause it and make sure you get those fixed before moving on to the next one. And our next problem, we have a rhombus, which the area formula is the same as a kite. Diagonal 1 times diagonal 2. And this one, we had to figure out what the full length of the diagonals were, because they only gave us what half of them were equal to. But because we know they are bisected, we can figure out the full length. So this one, we're going to have 1/2 times 60 times 80. And when we take that, we're going to have 30 times 80. 3 times 8 is 24, and then add the 2 zeros on there. So this one would be 2,400 meters. If you did not get these correct, feel free to reach out to me and we can go over some more examples together. But it is important that you know how to use these formulas to find the area. Example 3 is a word problem. For this one, they tell us that one diagonal of a kite is twice as long as the other diagonal. And notice for this one, they don't give us a picture. So you're going to go ahead and start the problem by drawing a picture of a kite. And it doesn't have to be perfect, just so you know it represents a kite. And if this one is going to be our first diagonal, that's going to be represented by x. You can choose any variable for this. And the first sentence told us that one diagonal is twice as long as the other. So because we define the first diagonal as x, the second diagonal is going to be 2x. The next thing they tell us is the area of the kite is 72.25 square inches. What are the lengths of the diagonals? So I'm going to make sure to highlight that so that I remember to come back and answer the question they're asking for. And because they gave us the area, we're going to start by using the area formula of the kite. So we're going to have area equals 1/2 times x times 2x. And we already know that area is 72.25. Now, when I start this problem, I'm going to want to simplify the right side of the equation. And when you do that, you can go step by step by multiplying those together. So 1/2 times x is 1/2 x times 2x. And then when you have a problem like this, you multiply the whole numbers together. So 1/2 times 2 is equal to 1, so we don't have to write that down. And then we have x times x, which is equal to x squared. And our last step to figure out what x is equal to is by taking the square root. And you can type that on your calculator. And the square root of 72.25 is 8.5. Now that we know what x equals, we need to make sure that we go back and answer the question they originally asked. And that is, what are the lengths of the diagonals? So we know D1 is equal to x, which we found to be, 8.5. And this one will be inches. So then D2 is double that, or that times 2, which is just going to be 17 inches. And that's how you can use the area formula to find the length of a diagonal in a kite. If you have any questions on this section, please reach out to me and I will get back to you as soon as possible.